So for Sushiswap V3, we needed path. Amount in is the amount you want to swap. So for USDC to wrapped Ethereum, we are stating, oh, we want to swap 10 USDC. Then we are telling it that based on the market condition, this is the minimum output amounts of worth we want. Path is telling it that this is token in USDC is the token we want to put in, and we are interested in getting wrapped Ethereum back. So you state it here as the path. Then where it will send our swap to is this contract. Block.timestamp is telling us the current time plus duration. So this is how we stipulate the deadline, that within the next 15 seconds you must complete the swap. Now it returns an array for us of amount in and amount out. So in position 1 in the array is where what we are interested in is. All right, so Uniswap V3. Now let's go to the next dex, and it's alien base. For alien base, this is the function for alien base. What are we interested in? Alien base uses exact, as I said earlier, the same interface as Uniswap V3. So we are calling exact input. We put this parameter, and this struct will help us. So over here, that's how this function implements it. We are calling exact input with these params, and this params is a struct that we imported from Uniswap V3 router interface. Then we put our token in, token out, the pool we want to swap in. Then the contract is the recipient, the amount of token we want to swap. Then we calculate our slippage. All right, so then we return the amount out. So we finished with Uniswap with alien base. So swap on alien base, this function 2 will be called by this internal function execute triangular trade. All right, so then the last one would be Aerodrome. That's the 5th one. Now, let's see what we need for Aerodrome V2. Aerodrome V2, we are calling swap exact tokens for tokens, amount in, amount out. The root is a struct, and we need to pass it in. And instead of passing in latest price, we'll be using get amount out. So let's implement that. So this is the function we need. So we import the roots here. Then we populate it with the necessary parameters: token in, token out, stable false. We are not swapping stable. Then we have error factor address we pass in from the constructor. Then this comes in here. It's part of the function, the parameters to this amount in is one of the parameters we pass in to swap. Now there's a function here, get expected output error, that we use to calculate our amount out minimum that we've not defined. So let's define it. Yeah, get expected. Now, as I said, instead of passing in latest price as we did for other dexes, latest price, and we use it to calculate our amount out minimum, in this case we are able to get amount out. We can call this get amount out on Aerodrome router, and it will simulate our swap for us and tell us what we are possibly going to get, what our output amount would be. Then based on that, we can calculate like 99.5% of it, which is our slippage, and use it to define our amount out mean. Alright, so at this point, please pause the video, copy the code, and if you are following me so far, thank you for your attention, and please don't forget to like the video, subscribe. It helps me to promote to create content like this. All right, as before, we are going to call swap Aerodrome V2 internal function. We are also going to call it here too. We're going to call it here too, based on what we pass in when we are doing the flash loan. Now is a good time for us to check if our contract is still compiling. But before we do that, you can see our constructor is accepting more parameters than usual, than before. So we are going to come to deploy script and update our contract. All right, so we need to define all those parameters we need. Now we need Uniswap V3 contract address. I'm going to leave the link to Uniswap doc. You'll find the contract address there, and you can also check it out on Basecamp, the Explorer, to see the contract itself. We need Aerodrome V2 router address. Again, you can see the link to the Aerodrome doc in the description below. We need Aerodrome factory contract address. This is Pancake V3 router address, Alien base router address, Sushiswap V3 address, and Sushiswap V3 router and Sushiswap factory. All right, so let's see how we arrange everything in the contract. All right, so let's copy this and let's see how it is arranged here, so that we don't keep coming back and forth. So I'm going to keep this here. Okay, just going to comment it out so I know. I'm sorry, we don't need this, so let me just remove that. All right, so what do we need? So V3 router, that's the first one here, so I'll put it here now. The next one is Aerodrome V2 Aerodrome V3 router. This should be Aero address here. The next one is factory router, Aero factory router. Then the next one is Pancake V3 router, Alien base router, and Sushiswap V3 router. I think that's about everything we need. All right, so fingers crossed. Let's now try and compile again and see if it compiles. And what do you know? Everything compiles well. All right, that's good. Now we can hide our terminal and let's go back to the contract. At this point, let's now try and identify our dexes. So we'll assign a unique code to each of the dexes. So if you want to call Uniswap dex, it will be 0. The code for it will be 0. The index for Aerodrome V2 will be 1. Pancakeswap 2. Alien base will be 3. And Sushiswap will be 4. That will allow us to easily refer to them when we are calling the contract. Now let's look at our internal functions for each of the swap So for Uniswap, you can see the parameter it's taking, amount in, token in, token out, pool fee, latest price. About the same for Pancake. Sushiswap, okay, it doesn't require pool fee. Sorry, let me just delete this. Okay. Alien base, then Aerodrome. So in order to ensure that we don't run into trouble, we don't have this error code stack too deep, we are going to create a struct, and that's how we are going to pass these parameters in. So I'm going to create a struct here. I'm going to create a struct here. And this is how we are going to be able to pass all these parameters into our start arbitrage function. So the struct is arbitrage params. It takes in the assets we want to borrow, the amount of the assets we are borrowing, the user address, that's where our profits will be sent to, the latest price that we'll use to calculate minimum amount out, the path, the dexes we are interested in using based on the arbitrage opportunities we have identified, the routers, that's the address of the routers of the dexes, and the pool, the fees of those dexes to identify them. So I'm going to come here now, start arbitrage. So instead of passing these two parameters, I'm going to pass this struct called data, and we call it arbitrage params. So this is what we are going to pass in. All right, so this arbitrage params is what we are going to encode here. So it will be sent alongside our call for flash loan. So these assets will come from our params, and the amounts will come from the arbitrage params. So this is how we pass our call for flash loan. As I said earlier, when we call pool for flash loan, it calls this execute operation, and when it calls execute operations, it calls back with this our encoded data here. It comes back as params. So we'll come here and decode it. All right, so let's now decode the params sent from the pool factory. All right, so this is how we are going to decode it. We'll decode it as our params. We'll be using memory. Yeah, it will be loaded to the memory. Then this is the structure we are going to be using, the structs we are going to be using, or to decode the params. All right, so after this, we now have all the params that we sent in here. We now have it available for us to execute triangular trade, then pay back the flash loan. So let's jump back to our triangular trade function. Let's complete this function. All right, so here in the execute trade function, this is how we are going to be calling the dexes. Just give me 1 second, then I'm going to explain all of this. All right, we need to define the parameters we are taking in here. These are the parameters we are taking in. All right, so the execute trade triangular trade function takes all the parameters in. What is looking for is based on this dexes path, is checking the code in the dexes path. If it is Aerodrome, it will call swap on Aerodrome internal function and swap on Aerodrome. If it is Uniswap V3, it will call the respective function. If it is Pancakeswap, it will call Pancakeswap. But you'll notice something here: current amount out. Now, the amount we want to swap is the amount in. So let's say we want to swap 10 USDC now. This current amount out starts as 10 USDC. Then the first trade we are going to, let's say we want to swap on Aerodrome first. So we convert USDC to worth first, then we convert worth, so USDC to worth on Aerodrome, then we convert worth back to USDC on Sushiswap. That's what we want to do. So 10 USDC goes into Aerodrome, and after it does the swap, let's say it gives us 1 ETH, for example. So 1 ETH becomes the new value of current amount out, and for the second time, it's going to use 1 ETH as the amount for the ETH, the wrapped ETH going into Uniswap, and we'll now have the final amount of current amount out, which will be around maybe 10.4, 10.2 USDC. That will be the final swap, and it will return that final amount of USDC. So we are still having error on this because we have not defined this error. So I'm just going to come here, up here as before, and define this error here. So this error, invalid dex index, comes out. It gets called if we are the dex, we entered the wrong dex index code. We are getting error here. This Sushiswap V3, we have actually removed the pool fees, so I forgot to remove that here. Yes, so I'm supposed to delete this pool fees, and everything will be okay. All right, it's okay now. Let's now call our triangular trade. Execute triangular trade internal function here. Since we finished writing it, so the amount out is here. So we pass all the params in, the latest price, path, dexes path, and everything here. Then it calls this function and it does what it's meant to do. So a quick recap on how this execute triangular trade works. To where we started from, I've added some values here to make it clearer. So what's execute trade function does is, let's say we tell from our parameters, we pass in at least two dexes. So we are saying it should swap on Uniswap V3 first, then Aerodrome V2. And let's say we are swapping 1,600 USDC. The price of worth wrapped Ethereum on USDC on Uniswap V3 is 1,600. So it takes in 1,600 USDC and swap it to one worth on Uniswap V3. So the output, the amount out on Uniswap V3, the output of it is the input for the second dex, which is Aerodrome V2. So it takes in one worth onto as input into Aerodrome V2, then it sells it at 1,601, and we get 1,601 USDC. So you would have noticed that we started from 1,600 USDC. Now we are ending up with 1,601 USDC. So that 1 USDC is our profits. So that's why we are looping. We are passing array of dexes. In this case, it's just going to be 2 elements in the array. So we'll loop through it for the first time, swap on the first dex, then come back the second time, swap on the second dex. The final amounts we have, we'll pass it here. All right. So I want you to pause the video, write the code, and don't forget the execute trade function returns bool. All right. So I want you to code along with me so that you understand what we are doing. Now, let's now check. We now have our final amount out. Let's check whether our arbitrage is profitable. So over here, we are going to check after we do the swap, the amounts we are getting compared to what the debt we are owing. The debt we are owing is the flash loan we collected plus the fee, which is the premium. So if the final amount we are getting is less than or equal to the total debt, then it's not profitable. We are going to revert. Now, reverting here means that the flash loan would not be taken in the first place once it's unprofitable. That's the way it works. The blockchain works. Once the transaction is reverted, all the state changes we have made so far, everything will be reverted as if it had not happened. So we are just going to lose the gas fees we have paid so far. All right. So let's just come up here and define the new error we have just added. Error arbitrage. All right. Profitable. So let's delete these unnecessary comments. That's quite good. All right. So this revert, we also need to be able to transfer the profit. If it is profitable, we should be able to transfer it to ourselves. So we are going to use these internal functions we created earlier. Send token. We are going to use it to send the profit to ourselves. So this over here, come here. So we can now uncomment this. We get the profit. Then we transfer the token to the specified user address, which will be our wallet address. So let's remove these unnecessary comments. Execute triangular swaps. Let's keep it that way. I need this profit to be included in this event. Yeah, we commented it out before. Now we can calculate our profit and test. Before we compare, there's one more thing we need to be able to do. I'm going to add a getter function to get the current slippage. So the current slippage in the contracts, we will be able to get it by calling this getter function. So that's about it with this contract. Now let's see if we are still able to compile, because we've added a whole lot of functionalities now. This is good, not bad. The challenge is coming from our interaction with bots. Yes, this script for interaction. Let's do it this way. Maybe we should just comment everything out for now, and let's see if we can compile now. Okay, it's compiling. That's good. Everything seems to be working well. Let me delete this unnecessary comments, and let's push our lock a bit forward and see if we can deploy now. Then we'll now try and interact. Okay, I've not started my local network, so I'm going to start that now. Make Anvil. It's coming on. So it's running now. All right, so let's deploy. Hopefully it works. Still deploying. Because we are using public RPC. It's taking a bit longer than usual. And everything seems to be okay. Let me not celebrate early. Wow, what do you know? This is quite good. So we've been able to deploy the contracts. This is quite good. So the next thing is to interact with it.